This is TempleOS 5-minute random code walkthrough episode 82, and I'm your host, Terry Davis. And it looks like we are in Strut. Okay, so in the apps directory, there's a directory called Strut. By the way, the convention, the standard way to make an application is you make a load file which includes the code, and you make a run file which calls load and then runs it. And that's how you distribute an application. And so this application, here's what it does. You place masses and then you connect with springs, and if you then you can make a connector. If you press a number key, then it puts a number on. I'm going to press number 2. Okay, what this does is these springs will break when I press a 1 or when I press a 2. And then finally thrusters. So thruster, when I press a 1, thruster 1 is going to go. When I press a 2, thruster 2, 3, 4. Okay, now I hit the space bar. Now the most impressive feature is zoom. If you do Z or Shift Z. Anyway, now 3 and 4 are those thrusters. Now watch what happens when I press 1 or when I press 2. And I do 3 and 4. Zoom. Okay, so that's the application. It uses mass springs from, it uses the differential equation solver and mass springs. What I should do is there's no point looking at this application. Why don't we look at demo games mass spring? This is simpler. What this does is it's random. Oops. How do you do a spring? Left, right button does a spring. Okay, so these are masses and springs, and they are live. Okay, so this uses a differential equation solver. They call it numeric integration. ODE. Okay, so you have masses, which have a masses and springs, and you can it actually, okay. So how am I going to explain this? You call ODE new. That makes a structure that will solve differential equations, and you don't have to make masses or springs, but if you make masses and springs and attach them to that, then it will simulate those. The way you use the differential equation is you make a derivative function, and it already handles the springs, but this what the derivative function tells is okay, the derivative of position is velocity The derivative of velocity is acceleration. And anyway, you have to tell it force equals mass times acceleration is the differential equation for physics. And it already handles, I can show you in the math. It handles the springs and masses. It already does some of the work for you. You know, it might be better if I got rid of, it's kind of an, I don't like physics engines and stuff like that very much because I'm a do it, not invented here syndrome is my favorite. And so I'm a hypocrite. I should not force you to use. So this is, when it calls the derivative, it calls, where does it call your derivative? Here's where it calls your derivative. And then after it's done, it does the force equals mass times acceleration. It does some more it does some more calculations to do F equals ma. So in other words, if you want to use the built-in masses and springs, it will already calculate the it will already there it does acceleration is the derivative of velocity. And or here I think it deals with mass. You divide by the mass to you divide by the mass, and that's how you get F equals ma. Anyway, I'm sorry, you probably don't understand a word I said. Anyway, so you make a derivative, and then it automatically in the just like it updates the screen automatically, well, it updates the differential equations automatically. So here's where it initializes. You have to give it the derivative function, and I set it up with some drag so that it, in this application, they dampen. You see how they stop moving? Watch what happens if we get rid of I'm going to put 2 zeros in here and 2 zeros in here. Now watch what happens. You see how they're vibrating a long time? I think I can, anyway. Okay, so that's, oops. Shucks. Anyway, I just want to make sure I put it back. So you set the, I put a limit on acceleration. Sometimes it goes spastic if you, it freaks out if it gets errors. And anyway, now this sets the tolerance. If you want to know how this works, this is an adaptive step size. What it does is it calculates it, let's say, with fourth order and then a fifth order, and it uses the error in the fourth order is estimated by assuming the fifth order is perfect. And so what it does is it slows down the step size when there's a lot of error and backs up. Anyway, so it's a fancy algorithm, and it's built into the operating system, into the window manager. And then, so I place masses, place springs, and it automatically moves them around based on the derivative. And then I go through the springs, and I draw the springs, and I go through the masses, and I draw the masses. So anyway, well, good luck.